Ahead and get going. Welcome everybody. My name is Gene Jones. I'm the executive director for a nonprofit organization called the Southern Waste Information Exchange. We're kind of like a 30-second elevator pitch here is we're a nonprofit that assists industry and municipalities with waste issues. We kind of act like a matchmaker. I put waste generators in touch with waste users to encourage recycling and reuse of waste materials. We'll go into greater detail about the specifics about how we got involved in doing this conference itself, maybe later on today in another session that I'll moderate. But for now, allow me to make a couple of opening comments in terms of admin. First off, the final program is in front of you. The agenda's all laid out. We will be shooting everything that you see here today to PDF. All the presentations will go out to everybody. We are recording via Zoom. Welcome virtual attendees. Glad to have you join us. I'll be compiling everything and then sending that out. It'll be next week before you all get it, but I promise you, you will get all the proceedings, the presentations, and the recordings. The other thing I need to point out with regard to that is we do provide a list of attendees, names and affiliations only for regular registrants, and then our sponsors and exhibitors, speakers, VIP registrants are going to get the full database. So if you don't want your contact information released, please let me know before you leave the conference. Bathrooms, hopefully staff has told you, they're out across the hall into the main registration for the hotel. I've got a handout table. If anybody has any other handouts, you're welcome to provide them on the handout table. And that's pretty much it, admin, other than silence your cell phones if you can. Lastly, conferences that we put on, in fact, any other conference, I don't care whose conference you go to, wouldn't be possible if it weren't for the sponsors. So I have to give a great shout out to our sponsors for kicking in the funds, as well as the supporting organizations that help us get the word out about the event. So with that, I'm going to turn it over to Ted Kaiser. We're going to run into our opening session. We're going to talk a little bit about the market, a little bit about the availability of plastics, how much is out there, and then we're going to talk about end markets. What do you do with all the plastics that we generate and recycle, and where's a good end-use market for it? So with that, Ted, I'm going to turn it over to you to control and run the show. Thank you, everybody.
Good morning, and we have a great first panel here to start us off today. But first, I'd like to thank Gene and his staff, the entire staff of the APRC, for putting together this conference. And I think everyone's had some really good networking and discussions already, and it's thanks to them that we're able to have this in our little area that is often forgotten about of agricultural plastics. So I'd just like to give them a warm round of applause for setting this all up for us. And our first speaker today is Dr. Steve Wong, the CEO of Fukutomi Green Products. Dr. Wong is one of the foremost people in the world to speak on recycling markets and the outlets for agricultural plastic. I've had the pleasure of being with Steve at numerous conferences over the years, including in many different countries, and there's no one better to talk on the topic of the global dynamics in recycling markets for agricultural plastic than Dr. Wong. So please welcome Dr. Steve Wong.
Good morning. Good morning. Thank you for the opportunity to be here, and also thank you for the introduction. I start with this, first of all, introduction about the market dynamic and also availability of plastic globally, as well as percentage that used in the agricultural industry. The whole world actually consumes about almost close to 400 million tons of plastics. And out of these, for the agricultural application, use about 4%, which come up to 16 million tons. And interestingly, I'd like to see the biggest application is packaging, 44%, and also building and construction, 18%. I actually think about where these materials are used in the agriculture, in the construction and also building industry. But anyway, let me move forward to look at individually where these plastics are used in the agricultural industry. So here we are. This number, in fact, coming from around about 2020. And I think at this moment, we are now 2024, there should not be much increase, possibly maybe 2% per year. And with this, we will see the allocation of different plastic in the agricultural industry amongst in the globe. Like China had 29% and Japan 4%. I would see probably China is the most use of the agricultural plastic in this sector. And now we will see different kind of plastic in different sector. We have, maybe I'll look at this one more easier for me. Okay, the most used is a greenhouse film. And one thing about greenhouse film is, later on you will see this is the most recovered agricultural plastic due to their thickness and also the recovering rate. And the worst one would be mulch film. I think everybody know that with the recycling rate, later on you will see only a recovering rate about 20 to 30%. I don't really think that this being recycled much at this moment. So we will also have a silage film, pesticide containers, and also fertilizer coating or fertilizer bags, and so forth, so on. So this is the chart or table I make up myself because I don't really can find some of the information from any of the media or any of or the countries as well. So what I have is I pick out the most popular or most used agricultural film and also drip tape, drip hose. And I work out with the economic aspect of the recycling industry when it comes to recycling of this plastic from the agricultural sector. So I start with mulch film. Mulch film at this moment, as we just saw earlier, that the percentage and also the tonnage being recycled and also used. Okay, I listed out number one, or column number one. We have mulch film, white film, drip tape, drip hose, and also greenhouse film. And then the next one is consumption rate among all the agricultural plastic, and where the recovering rate. I think recovering rate is something that I must stress. In mulch film, for example, most they are used in California. They are used in strawberry, and strawberry film. Strawberry, when you use them, they use together with drip tape and because it's very, really thin, they always contaminate with moisture and also sand and mud. So I actually give a number. 30% is the recovering rate. And then the second one is white film. White film normally, it doesn't really touch the ground, but it got moisture. Then I have the rate of 60%. And drip tape, depending on how tapes are being collected, and from my experience, it's about 50 to 60%, depending from which area and also how these things are collected. Then we have drip hose because they're relatively thick. So that's why we get sometimes 80%. And we also have greenhouse because of the thickness of the film, so we have 70, 80%. Then next column, I put down some number, the export price, and I don't know whether this is the representative, but this is something that I have my experience. So for mold film, because of the cost for collection, so I always put something in it, like $50 for the cost. And then we have wine film, drip tape, and so forth, so on. So you come up, I'm assuming that these waste are now being recycled, most of them, in the export market, like Malaysia, Thailand, Vietnam, and other Southeast or low-cost countries. Then we also have the next column, the processing fee. The import cost, import cost, I've given example of Vietnam. I didn't use an example of Malaysia because Malaysia is too expensive in terms of like labor and also other stuff. So I use Vietnam as example, $100 per ton, and then I also put down the cost of processing. So processing normally involved in shredding, washing, and also pelletizing. Depending on the material, some of them might cost more money, some of them it might also involve in a lot of tear and wear, and ultimately we have to spend lots of money on the machinery. I just give a rough idea, from $325 per ton to $425 per ton, including the import duty. Here it comes for the green column. So this is the column that, let me see this word. Yeah, so this is a column that I must stress because of the low recycling rate. So our recovering rate for every ton that being recycled, because of the wastage, because of the recovering rate, so you come up a very, very big amount. And then the next one, comparatively, here are the prime prices. I put 1,100 per ton, so this work out like 50 to 55 cents per pound. And this is an average price that in China or Southeast Asian country are selling. And then you compare with the last column, it doesn't really make sense because the selling price of all these recycled agricultural pellets are not really competitive, because a lot of people, they rather use prime material from the economic standpoint. So I don't go to the detail one by one because of the time constraint. So here are the example of like mulch film, and I mentioned about strawberry film or used in the strawberry or growing of strawberry. Then the silage film, we also have almond film, which is like with the recovering rate of 60-70%. So here's another example, drip tape, and we also have drip hose. Drip hose is more thick, but this drip tape. There's some more example of that. The thick one, the more round one is drip hose. So we also have a greenhouse film. Some of the greenhouse film could be very clean, but the pictures show might be some of the example. Okay, here are the pellets. You notice that the black one could be drip tape or drip hose or mulch film, but then the transparent gray. So these are it could be any of the greenhouse film, and these are not comparable mechanically and chemically to the prime material. So that's why there's no incentive to use, there's no reason economically to use recycled material from the agricultural industry. So here are some more example of drip tape. Okay, so these are the global market dynamic for recycling of agricultural plastics. I start with the Basel Convention. Maybe in the U.S. people may not be really, may not be aware that we are in a very lucky country that we still can export. But in most of the, like EU and also the rest of the world, when you export anything like this, literally you're not allowed to export because of the contamination. But at the same time, for importing countries like Malaysia, Vietnam, and Philippines, each country, they have their own interpretation of the Basel Convention Amendment with the specific wording almost free from contamination. I'll give example like Hong Kong, where you can only import anything with less than 0.3% contamination. Luckily, in Malaysia, you still can import anything that they can recover 95%. But when you come to this, like, when you come to import of this, any waste, including agricultural waste or agricultural plastic, luckily they don't really implement correctly. So that's why we still can import. But then for export, we see less and less agricultural waste or scrap. I always call it scrap, by the way. I think most people call our resource, our recyclable, they always call it waste. But I always call it scrap, you know. So for this reason, this is one of the challenges that material can export or material can be recycled, can be used, but cannot be exported. And then when you really want to export, under the Basel Convention Amendment, you actually need to have a prior informed consent. And but it's very, very difficult to have the prior informed or we have to have the notification, I would call it. We also have a technical term called PIC, prior informed PIC consent here. Okay. So now I come to the one of the problems we have is contamination. So you need to descend them, you need to dry them, but I don't think this is really viable. And we had looked at different situations a few years ago, and I even visited a place together with Eugene to see whether descending is workable at source. I would call it at source, yeah. But ultimately, apart from infrastructure, it's also a matter of economics. So there's many options. We also heard about people talking about like collaboration between recycler and also farmer or grower. In the end, I have seen a lot of examples that the recyclers gone bankrupt in California, as well as in other countries, due to the cost of recycling, and also regulation is also one of the things. To set up a factory is very expensive. I myself, I have experience of recycling, I think more than 20 different types of plastic from the agricultural industry. Ultimately, we also lost tons of money and not able to continue or to operate. But at the moment, we see more people going bankrupt than surviving in this industry when we talk about recycling. So hopefully we will see some remedy or some solutions. So these are the challenges that I just went through, and I'm not going to put much emphasis on this. Instead, I go to the opportunity or solution. Yeah. I also like to emphasize that at this moment, I think we have lots of like regulations, we have lots of talking, discussion, and also at the UN level, we talk about EPR, and we also talk about recycled content. We hope these things will come to or come up in the end as a mandate, because we have lots of like voluntary use of recycled content, but it doesn't really work because from my experience, I see people talk about sustainability, talk about how good it is and with sustainability, and also we talk about environment. But when you come to like cost or price or economics versus sustainability, I think most of the time people choose sustainability, especially nowadays. Prime prices are so cheap. And it's so cheap that I think if you take inflation into consideration, we never have so low price of the prime material. And this overcapacity, especially in China, give really a very, very big impact. Even our industry, when you talk about recycling, regardless whether this is from agricultural industry or from the normal recycling of household waste plastic, our competitors is actually the prime material producer. Prime prices are so low that, and I don't expect there will be any turnaround in terms of prices, in terms of overcapacity before 2029. So what we need is really a policy or really a mandate to use it mandatorily instead of like voluntarily. Another example I can give is, just now I mentioned about the most used plastic is packaging. And packaging, there are lots of brand owners, including, I also can name, the name like Unilever, and also the other one is Nestle. They recently go back to their word or commitment using recycled content. Instead of like 25% or 30%, they now said for different reasons, they now will reduce the use of the recycled content. Plastic itself, different than other resources, because once you use it, the mechanical and chemical property drop. So, and then for the brand owner to make commitment is one thing, but to use recycled plastic, for them is a lot of hassles because you have to blend so much prime material and the quality might not be as consistent as it should be. So I even heard about some of the brand owner or some of the people, some of the manufacturers, they actually buy the recycled material as recycled content as a sustainability program. In the end, they did not really use it, and they probably sell it again as like waste. Nowadays, we just give an example of like mulch film. It costs like $2,000 something to process or to process it. In the end, it's also off color. Instead of using this, they probably use prime material. So we talk about the EPR, extended producer responsibility. We need to have a system. We need to have a different program to collect. But then the thing is, I noticed that unless there's something from the United Nations, and I happen to be an observer in the UN, the environment program. So we discussed a lot of the different possibility or discuss different alternative to promote or to use more and more plastic waste, or I would say at the moment the rate that being recycled is only 9% globally. And this is challenges for the whole world. And we are really, all of us, it's also our commitment, our obligation to find a way to use more and more recycled material. At the same time, from the economic standpoint, it doesn't really work. So we need to have regulations. We need to put all the effort together, not only from the government, but from all the stakeholders along the recycling industry. So I see there's also different alternatives like chemical recycling, but ultimately in the end, at this moment, I still think about EPR. I still think about regulations, mandatory. I don't really believe in the voluntary use of the recycled plastic or recycled content from the agricultural scrap or agricultural application industry. And the next one, I think I leave the questions now, or I will. Oh yeah, okay, yeah.
Oh, Gene said to do some after each one.
Yeah. Okay. Yes.
So on your chart there, it had a drip tube and hoop greenhouse film.
Yeah.
Hear me?
Let me see.
Yeah.
In my chart, okay,
Yeah.
I make up this chart myself, okay, because I cannot get numbers from other sources.
I liked it. It was very informative. But I noticed that the total cost of every one of those is higher than the actual sales price. And, we're exporting quite a bit of material. Are we operating under a bubble? Like, basically, is this going to burst? And, like, was people operating under a loss at these plants at Southeast Asia that are receiving this material? I mean, you got 906 there for cost to process and 750 for the value of the resin that comes from it. Is this just a bubble that we're about ready to see a burst?
So you're talking about which one now, the cost, which one?
Yeah, if that's the cost, if that 906 from 2,250
okay,
to the cost to sell.
Yeah. Okay, how I get this number? I look at the 2,200, okay, because you only recover 30% of them. So you use the cost of recycling plus the cost of the material plus also import duty or import fees, and then divided by 0.3, you get this number. And lots of people, they don't really realize this until they do it, until they lose tons of money. Yeah, and then you look at this column, right? You also look at the one further down. Even you do the greenhouse film, still 900 something. But I must say, at this moment, I know there are people exporting, and also there are people who can afford to buy 14, 15 cents per pound CNF in Malaysia. But I know that there's a company, they recycle them into pellets and sell for sustainability program. Same as like fishing net. Fishing net, okay, before it was only $500-600 US per ton, but today it's worth a lot of money because there are a couple of companies they use back into the system by petrochemical industry, and also there's also chemical recycling of nylon 6. I just give an example like this, and with these people they are able to pay more than even prime material. Yeah. So I believe this is the because I also mentioned about I used to run the factory in Hong Kong. It's quite expensive for the labor, and we also use a Rayma, use the European machine, but it didn't work out. Yeah. Okay, thank you for the questions.
Oh, the recording. Oh, for recording. Oh, just like at home then. Okay, thank you. Well, let me just say, too, I think people need to be reminded the access to virgin material is very tough in a lot of these developing areas. So they have to go to the secondary market, right? One, they can't get credit, and they can't get access to material. So they rely on reprocessed and exported material, don't they? I mean, because you don't have the distribution network of virgin materials in a lot of these parts of the world. You just don't have it. So I was just curious what your thought is on that, because sometimes the market is repro. They just can't get virgin, so they have to get these materials from here and other places. That's been my experience.
Yeah, the reason I specifically mentioned about the market in Southeast Asian country, Southeast Asian country are the one that produce the most prime material. In fact, on one hand, you said there's access to the market for the prime material at that price. On the other hand, in Southeast Asian country, this is quite easily available for this kind of price. And then I also would like to say that with a capacity of like 400 million tons, 400 million tons is the application, is the produced quantity. But the capacity at this moment in China, only China, is 250 million tons. And I think there are lots of prime material being sold as off-grade. Yeah. So I don't know whether this is a situation that, do I answer your questions about this access to the prime material? So that's why you have to use secondary material. Yeah. But the situation in the Far East is quite different. Thank you. Okay, thank you. Thank you. Yeah.
Thank you, Steve. Our next speaker this morning is Katie Malarkey from the Rochester Institute of Technology. She's going to be speaking on an interesting subject that a lot of us have tried to figure out in the past, and that's just how much ag film and ag plastics are out there in use. So here's Katie Malarkey to speak about the quantification of agricultural plastics in the United States.
Good morning, everybody. Well, thank you for the opportunity to come and present my research into quantifying how much plastic use we're using in agriculture here in the United States. When I was fortunate enough to attend this conference back in 2021, I was just overwhelmed with all of the strategies and innovations that you guys were coming up with to deal with these plastics at their end of life. And so it sparked my interest in how we can connect data to all these solutions that you guys are developing. So the goal of my research, there we go. The goal of my research was to try to find the best available data from for all the different possible end uses of the different agricultural plastics, and to develop a model to show what kinds of plastic products and the polymer types that those plastic use in order to quantify that total mass of plastic that we're using every year here in the United States. This approach is similar to a material flow analysis, where the plastic mass is determined by the plastic products in each stage of agriculture. And the goal for doing all this is to determine the nature, the volume, and the types of plastic flows to help us better understand where the plastics are coming from and help us prioritize those end-of-life management solutions for some of the biggest culprits. So, the first step of the research was to determine where plastics are used in agriculture. I've broken it down into 5 agricultural stages of soil preparation, planting, growing, harvest, and storage. Now, many of these products that I included in my study, you guys are very familiar with, so this part might be a little boring, but there's pictures, so. The soil preparation stage includes preparing the land for growing, as you know, with the laying of mulch films, and irrigation, which utilizes surface drip tape, micro sprinklers with their mainline tubing, and subsurface tubing. The planting of crops was broken down into the categories of seed sowing and pesticide and fertilizer containers. The seeds can be delivered and stored in either the reusable seed boxes, like you see on the far side, or in more temporary plastic fabric woven bags or flexible intermediate bulk containers, which are also sometimes called bulk bags. Pesticides and fertilizers can be delivered in small jugs and larger drums, all 55 gallons or below, or in reusable rigid intermediate bulk containers. The growing of crops encompasses the field of horticulture, which uses plastic pots, larger tree pots you see on the other side, and liners and seedling trays for the propagation of those plants. Growing of crops under protection utilizes structures like greenhouses, which use the rigid plastic panels, high tunnels where you can use a plastic film or a shade fabric, and low tunnels for our row crops. The harvest stage includes plastics used for sweetener production, like the tubing that we find in maple syrup trees, and also polystyrene frames and foundations that are used for getting honey from our beehives. Forage crops, like hay and sorghum, are harvested for baling. They could either be wrapped in a plastic twine or a net wrap. And finally, the storage of those crops that includes plastic films used to ferment the forage in order to create silage, like bale wrap, bunker tarps, and the long silo bags. These silo bags are also used for overflow grain storage every year, and the flexible IBCs and woven bags that seeds use can also be used to store animal feed. So, calculating the amount of plastic for each of these categories every year was a multi-step process going from the ground up. First, we determined the end uses of each plastic product per category and the range of possible dimensions for each of those products, and I'll talk about that a little bit more. It includes both the minimum, the most recommended, and the maximum available options for every parameter that goes into those calculations for every product type. Next, I then calculated the intensity of the material that was needed per application. So in other words, how much plastic mass is needed per end use. That's dependent, as you can probably imagine, on the product form, its shape, the polymer density of the material, and the dimensions like thickness and width. But it can also be dependent on the method in which each of those products was applied or utilized by the stakeholders using them. Finally, we determined how much of each end use needs these products every year. This annual demand was found to be dependent on 3 different needs. Some of the products needed the acreage of crops grown or the area under protection, the capacity required to store a certain volume or mass of material, as for seeds and for animal feed, or the number of units manufactured or utilized, as with the case of horticultural containers. So we're going to walk through mulch films as an example. Usage was first determined for each of 134 possible crops via published journal articles, state cooperative extensions, virtual stakeholder interviews. The product dimensions were confirmed through manufacturers' sites and catalogs, and in this case, that would include the mulch thickness, width, and the polymer density. In order to calculate how much mulch is needed per acreage of coverage, the method of application had to be known. So a bed style of either flat, raised, or wrapped was determined for each type of crop, and that then allowed the amount of kilograms of plastic per acre to be calculated. And then finally, the annual demand was found by the acreage of crops grown, such as strawberries and open-air tomatoes, using data from the most recently released 2022 USDA Ag Census. So the first results I'm about to share will be completed for the baseline or the average usage calculations for everything, but uncertainty and sensitivity to these calculations I'll be discussing later. Okay, the final results of over 3 years of research. So for baseline parameters for all products, the total annual mass of agricultural plastics in the United States is 1,550,000 metric tons, or 1,670,000 US tons. That equates to 2.7% of all current US plastic usage, which is exactly on par with published studies from other countries that state that our usage is that their usage, depending on country and region, is between 2 and 4% of their total plastic use. It's also interesting to note that even though many of the published studies on plastic use include sectors that contribute less than 2.7%, there's almost no current published studies on US plastic that include the agricultural sector. So hopefully that will soon change. The last completed academic study doing this work to quantify this use was published in 1994 by the American Plastics Council. And this current updated research shows a 5 times increase in our plastic use since that time. Okay, now I'm going to break down the results stage by stage, staring totals for each category, and then also trying to discuss what drives those quantities for the largest categories. Soil preparation. So mulch and irrigation plastics use are both dominated by the crops that that utilize them, as you all know. So this is 2 of the categories where the baseline value might seem high, but that's where the uncertainty analysis later comes in, and all of that will be in the paper when it's completely published. But LDPE mulch was the second largest plastic product, coming in at 290,000 metric tons. And irrigation altogether for all 3 of those tubing styles was the 5th largest category at 84,000 metric tons. Deploying solutions, as you guys know and are doing a lot of talking about this week, is challenging because the usage of those plastics are so disaggregated. But for the example of mulch films, of the 39 crops with confirmed mulch use, the top 5 crops account for 60% of that total mulch use. So solutions could start by being targeted there, as I think some of you are going to be presenting on. Our lowest mass stage is planting. So this includes both the different styles of seed packaging and pesticide and fertilizer containers. All right, growing. Horticultural containers. These are the largest contributor to ag plastic mass by far. The liners and trays used for plant propagation are the largest mass by product type, and transplant pots and tree pots come in at number 4 and 5. So as a category, it is by far the most plastic that we use in agriculture. These plastics are particularly dependent on how long the containers are used for. So expanding their lifespan of their usage, especially through reuse, could significantly lower the total mass. Harvest plastics are our second lowest stage, with baling twine and net wrap for the bales coming together at only 3.5% of our total plastic use. Storage is dominated by silage films, not surprisingly. Silage bales that use bale wrap, or as my kids lovingly call them, marshmallows, are the third highest mass product, coming in at 160,000 metric tons. When you combine bale wrap with mulch films and the 3 horticultural containers in the highest category, those top 5 products account for over 70% of all of our plastic use in agriculture. Okay. Now, when we look at the breakdown of each of the plastic by their polymer type and the product form, we do see some interesting trends. The results show that low-density polyethylene accounts for almost 700,000 metric tons, or 46% of all of the plastics that we're currently using. The largest demand is linked to mulch films, high and low tunnels, silage wraps, and irrigation tubing. The next 3 categories by mass are high-impact polystyrene, polypropylene, and high-density polyethylene, respectively, which are accounting for 12 to 27% of that total plastic use. Polycarbonate, down there on the bottom, is slowly associated with the rigid plastic greenhouses in my analysis, and so that only came in at 0.3% of our total plastic use. The largest forms that the ag plastics come in, as again you probably all know, is the flexible films and semi-rigid containers. And while the polymers such as LDPE and HDPE do lend themselves to recycling at the end of the life, as you experts know in this room and have already shared, especially for films, the amount of adhered contamination like dirt after use can make those plastics particularly challenging to find a sustainable solution for. Okay. Now, as you might imagine, there's some uncertainty with these baseline estimates. For example, the baseline calculations for horticultural containers assumed that they are used for 1 year based on input from the Association for Professional Landscape Designers and a bunch of other resources. However, we know that their physical properties and other academic studies suggest that they could be used for longer. So in my soon-to-be published academic paper, there's going to be a large uncertainty analysis in there, but I'm going to go over the basics of that right now, so that way you guys know everything that I've done. So in that analysis, every possible variable from lifetime to the physical dimensions of any of the products to the utilization by crop or by end use not only had that most likely value, but it also has a minimum possible value and a maximum possible value. And those distributions of all of those values, I was able to put into an R coding program and run it through 50,000 iterations to see what the possible amount of plastic that will come out for each of those. So this histogram plot shows all of those possible outcomes for the total annual mass for all of the products that I'm talking about when you combine them from a best case scenario to a worst case scenario. So when you're looking at the best possible current options for these products, meaning the longest product lifespan, the minimal amount of plastic intensity per use, we can get down to as low as about 600,000 metric tons. While on the extreme end, you can go over 6 million metric tons. But as you can see, by grouping, there's not a high likelihood of either of those extremes happening. So why I want to show this analysis is it does show that optimization of even our current system of plastic use right now, even with our currently available products, we can still drastically reduce our overall consumption of those products. And so I wanted to spend a minute just talking about how to possibly optimize our current system that we can target through some of the sensitivity knobs that we can turn based on what these different products are. Which of these variables has an impact? So some of the examples include increasing the lifespan. Probably a no-brainer, but doubling the lifespan of currently reusable containers like seed boxes and rigid intermediate bulk containers could lower their total annual mass by half. Reusing horticultural liners and trays, our biggest component of plastic mass, if we can reuse them for just 3 years, that could reduce the annual mass of the whole horticultural category by 30%. Changing the product properties like the mass of the container or dimensions like thickness can also have a big impact. In the case of horticulture again, reducing the mass of currently available containers could drastically lower that overall mass. There's a lot of different plastic types that are used in that field, so it's a complex system that needs different solutions based on what is coming out at the end of life. So that could be dematerialization or substituting with bioplastics. But by finding that balance between the product properties that are needed to maintain their functions while also coupling it with trying to extend the lifespan of those products, I think we could really find a sweet spot to lowering that overall plastic usage. And that a little bit of that is on us because we are the end users for horticultural plastics for the most part. Cutting the thickness of plastic films for high tunnels in half could lower the plastic mass of the whole under protection category by over 20%. And the impact of the product's end use. So just crunching some numbers, but if we cut U.S. livestock quantities by a third, we could lower the mass of the animal feed packaging by 30% and the total silage plastics used by almost 40% because of the division of where those different silage plastics are used for that end use. Low tunnel usage is dependent on the crops that need them for season extension, and the quantities could be modified by what utilizes them. And I didn't make a note, but if we reduced the amount of overflow grains by half, we could completely eliminate the need for plastic grain silo bags based on the number of current U.S. permanent storage structures. Thank you. So investigating the sensitivity of these calculations to certain parameters allows us to look at how we can have an impact on the current total usage of plastics. So hopefully this research is able to highlight the volume and nature of plastics flows through ag in the U.S. so that we can prioritize and target the innovative solutions that you guys are coming up with today. And I just wanted to thank some of the people in the room who helped me way back in the data collection phase of getting this all together. The final paper is still being written, but it should be submitted for publication in the next few months. So if anybody is interested in getting that, once it's out there, let me know. And if you have any specific questions on or details on a particular product, I did bring all of my research and I will be through the end of the day. Or the same thing, if you have any feedback to share so that I can better optimize this research before putting it out into the greater world, I would welcome that. So feel free to come and find me. All right, any questions?
Hi, thanks.
Hi.
So when you want to spread this cost out over more years, right, which we're already trying to do whenever we have to use plastic containers for production, have you factored in, how would they sanitize that for pathogens, right, for their clean plant programs, and what's the carbon footprint of that? What's the impact of that, right? Why are we doing all of this?
Yes.
Right, trying to reduce plastic.
Yeah,
sure there's a carbon
it's
factor.
actually it's a wonderful question because I, as many of you know, I'm currently a PhD student, and the next phases of my research is actually going to be doing semi-structured interviews with stakeholders about how to bring these particular plastics more into the circular economy and what are the challenges and benefits of trying to take these different products and how can we get them to a more sustainable end of life. So find me afterwards. I'd love to interview you. Hi.
Hi, that's great. Glad to see that research. A bit surprised on the number of hort containers that Do they include containers that go to the consumer or just stay on the farm?
Yeah, so the USDA breakdown for horticultural containers is actually in the 2019 horticultural census. So there's a specialized census that actually looks at basically how many plants are sold and what containers they come in. So it's actually broken down specifically by the amount. So that's why when I say this is an annual study, it's not necessarily exactly 2022. It is over the span of a few years because horticultural data came from 2019. But yeah, the USDA actually breaks down how much of each of those are in the market every year.
So that summary includes what goes to the consumer.
Yes, yeah, exactly, yeah, and like I said, that is where, those of us that aren't, manufacturing or recycling ag plastics can have a little bit of an input because we can do something with our own horticultural containers.
Okay,
Yeah.
because I'm in Canada and we did a similar
Yes.
approach, but our hort container is much smaller because we only included what stayed on the farm, knowing
Yes.
that,
Yeah, no, this is yeah. I try to do this more, TED Talk style, but the description of exactly what is included in the study will be in the published paper, so thank you.
Hi, Katie. Very nice study, very nice.
Thank you.
I didn't see PVC in there anywhere, and I thought I had seen seedlings being grown in PVC. Is that included?
Yes, no, thank you for asking that. Most of these studies were looked at. There's also an analysis that comes behind this, because one of the other question is not just material type that could go into either of these products, but differences across the country. Like what one product might be used in New York might be used differently in California. So part of that uncertainty analysis is to look at, okay, we're assuming that all of this type of plastic was used for this particular product, but we're acknowledging that there might be something else. And I actually talked to somebody briefly earlier about maybe trying to add that as an inclusion into this study. So if you have feedback like that. I will say too, I didn't say it when I was on it, but for the uncertainty analysis, from a research standpoint, the average of all of those 50,000 iterations was less than 5% different from the baseline calculations. So even when you take in all of those possibilities for these products, it's still very close to the most recommended use or dimensions of those products. So, yes.
Did you look at or consider hydroponics as part of this?
Yes, so there is, when you look at the horticultural census, it actually does break down, I didn't use anything that didn't come specifically in a plastic container, so I didn't look at like the tubing or anything, but it's something I could perhaps add before, before getting this out. Thank you. Netting, somebody else mentioned netting. Netting was another thing that was just really hard to get real data for the end use of it, the quantities of end use. So thank you for the feedback. Anything else? All right, come find me anytime.
Thank you, Katie. And I have one question to kind of segue us into the next speaker. You might have touched on it, and maybe I also missed it because my angle is not so good at viewing the slides. But drainage pipes, HDPE corrugated, PVC piping. I think maybe you spoke to Dan about that a little bit. But where does that factor into some of your calculations?
So drainage pipes were not included because I wasn't able to say the length per farm, for example, from the pump house to where the irrigation tubing happens. So all the irrigation tubings are based on the acreage that the crops use in, which is something that needs to scale up. But what you're going to talk about is a little bit harder to determine.
Okay. Okay, so our next speaker is Daniel Currence. He's the Director of Engineering in the Drainage Division for the Plastics Pipe Institute, and he'll hopefully answer some of those questions for us about corrugated drainage pipe.
Yeah, I think you need to go to the beginning of my presentation. This is toward the end. And you all might be happy about that, but I don't have much to talk about if I start there. Thanks for having me. Appreciate the opportunity to speak to you today. There are seats down here front to your right. If you're looking for chairs, this would be the place to look. So I'm going to talk about why I believe corrugated HDPE pipe, drainage pipe, is the best green solution for drainage infrastructure and as a win-win for agriculture and recycling. And as stated, I'm with the Plastics Pipe Institute. I've got my degree is in civil engineering. I have a master's in environmental engineering, and so the combination of those, talking about recycled materials, right up my alleyway. So I've got a quick outline just to show you. I'm going to give you a quick overview of PPI, what we do, and how we're involved in agriculture. And then I'm going to give you the basis for why we're the greenest solution for the use of number 2 HDPE. So I've got various reports that I'm going to summarize for you just to show that it's not just me blowing smoke at you. It's based on good science. So with that, the Plastics Pipe Institute is a trade association, okay? We're not a school, nor we're not a home for crazy plastic pipe people. We are the Plastics Pipe Institute. It's a trade association for all plastic pipes except PVC. They've got their own trade association. So we're everything else. So primarily HDPE, but we get involved in PEX, some crosslink, polypropylene, and things like that as well. But by far, it's HDPE's the primary material use. We're split up and organized by sector of where we're used. So we've got a division that focuses on PEX and use in buildings. We've got power and communication, which would be conduit. We got uses for gas line, natural gas transmission, water line, high pressure water line, that would be municipal. I'm focused on drainage, which, as you can tell by the pictures, is primarily corrugated, is what we're talking about for drainage pipe. There's also a hydrostatic test board that evaluates material properties for folks in pressure pipe business. So when it comes to pipes in agriculture, the areas that I focus on is drainage, and that's in the Midwest, states like Iowa and Minnesota and Indiana and Illinois. This is where my industry began, was putting corrugated small diameter pipe perforated under farm fields so that farmers could get the crops in earlier because it would dry out quicker, and they could harvest later in the season even if it rained. Okay, so there is miles and miles of perforated drain pipe put underneath farm fields. This also put underneath your baseball fields and football fields, soccer fields, stuff like that for the same purpose. But in agriculture, there is some solid wall used in water transmission, and not drip tubes, but certainly in small hose and tubing of HDPE. So all those are agriculture uses. And just to make a real clear distinction, if it's a solid wall pipe and the pipe is under pressure, we're not putting recycled content into it today. The reason drainage is such a great space for it is because it's non-pressurized. It's gravity flow, so it doesn't experience pressure, and that's why, so drainage and conduit is the other area for plastic pipe where they can use recycled content. Now, we continue to work on it, and hopefully in the years to come there'll be other opportunities, but today it's non-pressure applications is where recycled content goes. So these are the material standards that where that recycled material goes in ASTM. That F667, that's the small diameter pipe. That specification has been around for decades, as you can tell by the low number. We've been putting recycled content into that pipe for 40 years, 50 years. It's a long time, okay? So we're not new at this. So the stuff you see at Home Depot, Lowe's, that type of thing, you may have some connected to your downspout at home. That likely has recycled content in it. And that's the same type of thing that's used in farm fields every day. And then more recently, that bottom standard came after a tremendous amount of research, which allowed us to use recycled content in infrastructure projects inside the public right-of-way. So culverts, storm drain, and that type of thing. So these are the standards where recycled materials can be used. And as I've said, I'm a firm believer that this is the best place for recycle number 2s to be used. We use carbon black in the pipe, and so it doesn't matter what color the recycled material is, it can be used. A lot of our producers can use straight flake, clean flake. Now, prefer to have it reprocessed. And the primary reason why they like to reprocess is they can run it fast. They can run their equipment faster. If they are using flake, it's a trickier recipe, so to speak, and processing through their extruder and making the pipe. If you can get it to them reprocessed, then they can run everything at a faster rate. And we produce this at a range of producing materials that we can document last 50 to 100 years. So this is kind of just a glimpse of what that research. It was about a 8 to 10 year process, about $1 million in federal government research, as well as private research dollars that we spent to result in both the ASTM standards that I have, but also for AASHTO. AASHTO is the organization that every DOT in the country belongs to, including Caltrans, and they, most, not all, but they have an allowance for recycled material to be used in HDPE pipe used underneath your interstate highways. So there's more opportunity for plastic pipe to be used. And so we promote, we can go from single-use plastic at the curb to 100-year infrastructure pipe under the curb if we can get the material. We currently use about 600 million pounds per year. My producers, who are my members, tell me that we could get to 1 billion if we could get access to it economically. And so I make visits to Capitol Hill and encourage those incentives that were talked about for ways to help encourage this. But we feel like, find us. We have manufacturers across the country, all of North America that utilize these materials. So with 600 million pounds, about 1 in 4 containers that are recycled ends up in a corrugated HDPE pipe. Just for some perspective, if everything were detergent bottles, we recycle enough to fill the Cowboys football stadium 3 times every year. So I guess that's why maybe the waste haulers don't like us, because we're diverting things from their landfills. So in addition to diverting recycled materials, we're also better for the environment than our competitors, our competing materials. We did a life cycle assessment a few years back. It was done independently. It was peer reviewed. It followed ISO standards, which is international guidance. And it concluded that of the materials that we compete against as plastic pipe producers, HDPE pipe is the best for the environment, and that's virgin is best for the environment. And if you use recycled content, it gets even better. And this is a graph that blow your eyes away. But essentially, you see on the left-hand side of that is virgin polyethylene. The next graph is with recycled content. And then you see the materials that I compete against, including PVC, concrete pipe, and steel pipe. And this is all indexed. All these 8 different environmental factors were the lowest impact across the board. A couple of specific ones: water consumption. Who uses water to produce their materials? We have the biggest reduction in water usage by producing our pipe versus other pipes that we can compete against. Global warming potential, big here in California. This would equate to greenhouse gases and that type of thing. Carbon footprint, this is as close as I get to quantifying that, is a global warming potential, and we are the lowest impact for global warming potential. So that's pretty good. Then the National Academy of Sciences just last year did some research through a gentleman with Carnegie Mellon, and he looked, it was mandated by Congress, but they were trying to find out, is there a great place for recycled plastic to be used in infrastructure? They were looking at tossing it into your mix of your pavements or different types of things. And the conclusion of the report, well, you see the report in the top right-hand corner. The conclusion of the report is we're the poster child. we are the best thing going in plastic, recycled plastic in infrastructure is drainage pipe. And you see some of the statements made. I really like the last one. I like being told that we have perfected the use of recycled plastics in infrastructure. I like that. I don't know if I would have ever said it, but they said it in the report, and it's economical. I haven't talked about cost, but I will at this point, is that we are not, you don't choose to use recycled HDPE because it's good for the environment. Most people choose it because it's less expensive, okay? There's a slight price decrease versus if you insisted, no, I want to use virgin materials only, then you're probably paying a little bit of a premium. But that fluctuates based on that demand. So anyway, the National Academy of Sciences study is out there, and so it's like, man, shout it from the rooftops, the world should know. How many people knew that we were the biggest user of recycled plastics before I started talking? A handful of you. Okay, the word's not out there. And so we're trying to find ways to try to get the word out there that we do this. And so we came up with this little video.
Can be used to produce superior materials that will connect us to our future, but you have to look deeper. HDPE stormwater drainage pipe like this can be made using most recyclable containers, and it lasts for over 100 years. In fact, the plastic pipe industry uses over 600 million.
For the whole recycling concept is that a lot of the public doesn't believe that the recycled materials ends up anywhere beneficial. And that's the point of this, is to show that, yes, you take your container to the curb, we can find beneficial use for it, and it'll be in your next storm drainage project in your neighborhood for the next 100 years. And so anyway, it's a little promo, but if you find use for it and want to say, if somebody questions you as you're in this business of trying to recycle plastics and they say, oh, but it's never put to any good use anyway, show them that video. So now I'm back to where I started. This is another study, just finished this summer. This was put out by another national study. It's by NIST. And the real rub of this study, if you are in recycling business, sometimes you'll get into arguments of whether it's best to be circular versus turn something that's single use into a durable good. And that's the whole purpose of this study. Which is better? Is it better to go container back to container, or is it better to go container back to a durable good like a pipe? And so they did the work, this group of folks and that research, a lot of small numbers here, but essentially looking at where is the best combination based on collection rates, usage rate, and all that. And I won't get into the specific numbers, but I'll just get to this. It's a little cleaner. The result was that turning your single-use plastic into a durable good results in 13% less greenhouse gases and 15% less water usage. I still think that bottle or container to pipe is therefore better for the environment than container back to container. I think that's what it shows. So I think all the data is there to show that, once again, using recycled HDPE pipe is the best solution to reduce. And I haven't mentioned in the lower left there. After that pipe's been in the ground for 50, 100 years, somebody can excavate it, grind it up, using flipping iron to go out and grind it up and send it back to a pipe producer, and they can make pipe out of it again. I think that's a pretty good green solution. So, in summary, I went really fast. So we're going to get to that break early. But 600 million pounds a year used. We have, like I said, we can go up to 100 years. That's what a lot of that research was about, was to validate whether you could. We have a 100-year service life for virgin materials. They wanted to validate, did we lose anything if we put recycled content in it? And that's what the research proved, that you can get 100-year service life. Now, Not all ag pipe is 100-year service life. I did not say that all ag pipe is 100-year service life, but we can produce pipe up to 100-year service life using recycled content. It's greener based on the peer-reviewed life cycle assessment, and we are updating that as well to include polypropylene pipe, one of the other pipes that my members produce. So we'll be adding that in the coming year. We're the poster child for the National Academy of Science report on plastic recycling and infrastructure. And bottle to pipe is better for the environment than bottle to bottle. So recycling your number 2 ag plastics is your win-win for agriculture. We're an agricultural product often, and we're also using agricultural plastic when we can, or any other number 2 HDPE. So it wouldn't be, do a little promo. We do have a website. You can find all our information, and we have a comprehensive handbook talking all about corrugated plastic drainage pipe. That can be found on our website, which I think I have here, slightly cut off in the bottom right-hand corner. But so again, you can find me, you can email me at dcurrence@plasticpipe.org or go to our website. You can find me there too. I'll take any questions.
Thank you very much. That was a great overview. Can you comment on, the world is moving towards recycled content in everything, like bottle to bottle and all that sort of stuff. What do you see this as a threat to the pipe industry, and
Right, because if, for example, there were mandates put out there that everybody's got to start using more recycled content, then obviously we have more competitors for that number. No, number 2 HDPE is probably the biggest demand market anyway, and so if it's put out there, then yeah, we increase it. That's why we want to increase collections, incentivize the collection. We don't want to just incentivize the use of recycle without incentivizing collection also, because collection is pretty good in urban areas, but I can tell you, I live in Kansas City. I live a total of 16 miles outside the city of Kansas City, and I have no plastic pipe collection. I don't have any drop location I can go to, and so it doesn't take too far from the cities. The other problem with collection is in urban areas, in multifamily locations, and having a good place. So it seems like the best collection for single-use plastics on an urban basis is suburbia. It's kind of the sweet spot. Inner city, not so good. Once you're outside that suburbia, not as good either. So trying to improve that is something that on Capitol Hill we talk a lot, but the work that you all do in agriculture is a great source as well. Yep. Yeah, I mean, we are trying, we can use a little bit, but in too much quantity, it's a contaminant, so have to be careful with how much is used, but it can find its way in, and it doesn't necessarily exclude it, but some manufacturers are going to want to cap it at a pretty low rate. We continue to, we do have polypropylene producers, and we haven't got to the point of funding research to try to get polypropylene recycled content into the polypropylene pipe that's produced, but it's going to happen at some point in the future. So we hope to get there as an industry. Yep.
Again, thank you very much. Very helpful summary. And a follow-up to Barry's question a moment ago. Given that very likely we will see much more volume going into recycled content, like bottle to bottle, et cetera, can you talk about what your members are doing, if you have knowledge of it, of they're trying to position themselves to be more equipped to handle difficult to recycle plastics. For example, I represent the Ag Container Recycling Council, so chemical containers. We've had some conversations with your members and understand that there is some activity around trying to be better equipped to handle plastics like ours. I'm just curious if more broadly across your membership, if you're hearing that many of them are trying to be better positioned in the event that they have more difficulty of getting supply in the future.
Yeah, that's a good question. So within my members, the largest member of or producer of corrugated plastic pipe is Advanced Drainage Systems, ADS. They own a few recycling facilities, none out here west. They have one in Iowa, Pennsylvania, and Georgia, I want to say. Maybe it's Kentucky. But anyway, and that continues to grow. Is that me? No, okay. I thought that was your alarm for me. I'm like, hey, it's... So obviously that's something that's just started in the last 7 years or so. So I've got one other producer who has a recycling facility themselves. That's in Western Ohio. But so that's a trend, I guess, that we could see more of is doing that. If you went back a couple of decades ago when we were using recycled in some of these ag applications, I think most of the producers were doing it more on they were first looking for post-industrial sources, clean products, high quality type of material, and so they would buy it kind of in batches that way. I think they're weaning themselves off of that because the problem there is that it's not consistent. And so every time they get a different batch, they have to adjust of what kind of recipe they push through. That's why, like I said, I think they like the reprocessed resins. And then I guess that's the other trend that I see is that there's companies who are focusing on that, give me all of it, I'll find the customers and I'll reprocess it for different customers. And I think that's something that's fairly new in our industry, and I think that's a good solution for those small companies who can't do all the chemistry themselves to figure out, okay, if I have this source and its properties are this, and I mix it with this, what is the resulting pipe going to be? So having somebody who can reprocess it, I think, is another trend that we'll see continue to expand. For those smaller producers who don't have the chemical engineering staff to evaluate it.
Yeah, you will see that because we're doing that.
Yeah. Yeah.
Thanks for the segue. Thanks for the lead-in, by the way.
So Ron's doing that, and I know we've got companies in Canada who are doing it regularly as well, and I think that's an opportunity because not everybody can do it the way ADS does it. So.
Well, and ADS didn't always do it,
Yeah.
right? I mean, the reality is, too, the question from Canada was interesting because actually you create a greater pull-through. Only 8% of plastics get recycled. So unless you have end markets for it, you're not going to incentivize it. So actually you create that better pull-through, which is better ultimately for you and your members.
Right.
Because it does create an infrastructure which is lacking today. It's so
Correct.
highly fragmented that only a small percentage is being taken and finding end markets. Export markets are still dominating the landscape, which is, not good, but hey, and nature abhors a vacuum, so they're going to find an outlet, and you need to find it. It is a global marketplace. But yeah, I think it's the opposite. I think the more you have end markets like this, the more you incentivize, to your point, the greater the collection will, and you will get more material out of that stream that's valuable and put into a higher value opportunity such as pipe and other durables for sure. So yeah, it's bravo.
Yeah, I was part of when we were working our way through the highway departments across the country, trying to get them to allow recycled material in the product that we put underneath their highways. I sat down with a lot of meetings with different DOTs across the country, and one of the common questions was, so are you going to put a limit on how much recycled you can put into it? And our answer to that is no. Now, we target typically, I think if you ask one of our producers, they target for about 40% recycled content. And so then, like I said, it becomes this recipe process of taking the recycled material, mixing it with some virgin, mixing it with a virgin with certain properties, and then having appropriate additives, because in the end, they've got to produce a pipe that has a post-production characteristic that meets all their standards. So that's the process they have to go through. And so one said, but how can you deal with all that variability? And I said, well, the good thing about post-consumer plastic resins is that it is consistent. It's consistently bad. And so you can assume that its properties are bad, and then you work from there. Now, like I said, in some batch situations, if they've got nothing but a rail car load of reground barrels, that's different. Then they could adjust to that. But if it's just post-consumer plastics, you assume that it's bad and you work it up to hit your marks. Yep.
Very nice show there, Dan, and I'll try to give you a softball here.
Okay.
I actually have two questions.
Yeah.
One, if somebody wanted to introduce a product to that industry from the ag industry, do we have to just cold call ADS, or is there a way, one, that we can market products? And it leads to my second question is there any way that PPI and maybe APRC or something like that can work together in qualifying products that can be used? The presenter before you, great presentation on containers that are how much containers are used in this industry, and I don't know what percentage of them are, but I imagine a lot of them are HDPE. Right.
Yeah, that's a good question, and it's certainly from conversations I had last night and interaction. I've had pictures shown me, hey, could you use this? And I can't just look at something. And so my first thought is, one, if it's a number 2 HDPE, we probably can use it. If it has been used in a pressure application, even more certain that I can use it. But there are limitations, and I don't know where that line is. I know that having seen some of ADS recycling facilities, they have a kind of a wall of shame of things that they don't want. If they process something, and they'll take it, regrind it, they'll melt it, run all the tests on it, and then it either makes the wall of shame or they keep using it. And so for all their sorters on the line, they have all these things that they will not accept. And so in my mind, I'm thinking they have a system to figure it out, but as an industry, we have not got there. Probably a fair point that could that be something we undertake as an industry to qualify things ahead of time? Maybe so. And anyway, we can look into that. Any other questions? If not, I appreciate the time. And I'm only here till noon. So if you want to reach out to me, please do. Happy to exchange business cards and follow us on LinkedIn or any of our social media so that you can keep up to date on things like these different reports that we share with our members. So thank you, and we'll talk to you at break. My water, your mouth.
So that concludes our first panel for the day, and we have a break now until 10:30 in the exhibit hall.